Confirmed, Newfound particle is the Higgs boson by Gianna Briner, Life Science Managing Editor. A newfound particle discovered at the world's largest atom smasher last year is indeed a Higgs boson, the particle thought to explain how other particles get their mass. Scientists reported today, which is on March 14th, at the annual Rencontre des Mondes conference in Italy. Physicists announced on July 4, 2012, that with more than 99% certainty, they had found a new elementary particle weighing about 126 times the mass of the proton that was likely the long-sought Higgs boson. The Higgs is sometimes referred to as the God particle, to the chagrin of many scientists who prefer its official name. So the mass of the Higgs boson particle, possibly uncovered at the Large Hadron Collider, LHC, in Geneva, may mean doom for our universe. Proton-proton collisions at the LHC showing events consistent with the Higgs. But the two experiments, CMS and Atlas, hadn't collected enough data to say the particle was, for sure, the Higgs boson, the last undiscovered piece of the puzzle predicted by the Standard Model, the reigning theory of particle physics. Now, after collecting 2.5 times more data inside the Large Hadron Collider, where protons zip at near light speed around the 17-mile-long, 27-kilometer underground ring beneath Switzerland and France, physicists say the particle is a Higgs.
Probably the largest scientific instrument that's ever been created.
At the CERN lab in Switzerland, huge tools are needed to detect tiny particles.
But the real action happens underground in a cavern attached to this 17-mile circumference ring. 3,000 physicists working on this huge detector. This detector is 80 feet tall, 140 feet long. So imagine that.
With support from the National Science Foundation, physicists Michael Tutz at Columbia and Kyle Cranmer at New York University are among the 21st century explorers who have been searching for the mysterious Higgs boson. It's a subatomic particle that gives other particles, like quarks and electrons, mass. So tiny, yet where would we be without it?
The universe would be a fundamentally different place. There'd be no life, there'd be no stars.
Inside the world's biggest atom smasher, the Atlas detector works like a huge digital camera. It records the collisions of hundreds of billions of protons at nearly the speed of light.
Our digital camera takes 40 million pictures per second.
Thousands of computers, like these at New York's Brookhaven National Lab, filter the images of those collisions, looking for traces of the Higgs boson, which decays quickly.
And the trick is not so much throwing stuff away, but making sure that you don't throw away the good stuff.
In July 2012, scientists celebrated.
We have discovered a new particle, a boson.
We've seen something, and that something looks like a Higgs boson. Now that we have this new particle, we need to study it like crazy. We need to measure all of its properties.
The elusive Higgs, also known as the God particle, has captured the imagination of non-scientists too. It even has its own music video.
This is a triumph of human curiosity. It's really key to our understanding of the universe.
Tutz and Cranmer say that at CERN, the Higgs is only the beginning. More exotic mysteries lie ahead, from figuring out what happened after the Big Bang to discovering extra dimensions of time and space. For Science Nation, I'm Miles O'Brien.
The preliminary results with the full 2012 data set are magnificent, and to me it is clear that we are dealing with a Higgs boson, though we still have a long way to go to know what kind of Higgs boson it is, said CMS spokesperson Joe Candela in a statement. Dave Charlton, Atlas spokesperson, agreed that the new results point to the new particle having the spin parity of a Higgs boson as in the Standard Model, referring to a quantum property of elementary physics and particles. To confirm the particles as a Higgs boson, physicists needed to collect tons of data that would reveal its quantum properties as well as how it interacted with other particles. For instance, a Higgs particle should have no spin at its parity, or the measure of how its mirror image behaves should be positive, both of which were supported by data from the ATLAS and CMS experiments. Even so, the scientists are not sure whether the Higgs boson is the one predicted by the Standard Model or perhaps the lightest of several bosons predicted to exist by other theories. Seeing how this particle decays into other particles could let physicists know whether this Higgs is in the plain vanilla Standard Model Higgs. Detecting a Higgs boson is rare, with just one observed for every 1 trillion proton-proton collisions. As such, the LHC physicists say they need much more data to understand all of the ways in which the Higgs decays. From what is known about the particle now, physicists have said the Higgs boson may spell the universe's doom in the very far future. That's because the mass of the Higgs boson is a critical part of a calculation that portends the future of space and time. Its mass of 126 times the mass of the proton is just about what would be needed to create a fundamentally unstable universe that would lead to a cataclysm billions of years from now. This calculation tells you that many tens of billions of years from now, there will be a catastrophe. Joseph Licken, a theoretical physicist at the Fermi National Accelerator Laboratory in Batavia, said last month at the annual meeting of the American Association for the Advancement of Science. It may be the universe we live in is inherently unstable, and at some point billions of years from now it's all going to get wiped out, added Licken, a collaborator on the CMS experiment. Scientists at the Large Hadron Collider say the particle outlined in July 2012 looks increasingly to be a Higgs boson. The Higgs, long theorized as the means by which particles get their mass, had been the subject of a decades-long hunt at the world's particle accelerators. Pallab Ghosh reports in BBC News.
Last year, scientists at the Large Hadron Collider felt they discovered the thing that the Large Hadron Collider was built to discover, namely the Higgs boson. Now they've had a chance to go through the numbers. They're pretty sure, but they're not prepared to call it. But a more interesting side of this story is that they wanted to find out whether the Higgs was what they call the Standard Model Higgs. Now, just be a little patient with me as I explain this bit. There's a theory of subatomic physics that explains only 4% of the universe. That's called the Standard Model. There are things going on that astronomers are seeing, like the spinning of galaxies, the continued expansion of the universe, that can't be explained by the Standard Model. So this theory of physics, this brilliant theory, can only explain 4% of the universe. So there's got to be something else going on. What they want is a new theory of physics, new physics. And they were hoping that by studying this Higgs, they'd get clues as to what this new physics might be, that it might be a supersymmetric Higgs, or there might be several Higgses. Now, they've ruled that out for the time being, so the mystery of how the universe works is even greater, if you like. So that's the main conclusion, that the Higgs boson that they think they've discovered is a Standard Model Higgs explained by this old theory of physics. They've yet to find any indication of what they really want to find, which is new physics, new supersymmetric particles, new things that are previously unobserved. So in some ways, it's slightly disappointing they haven't. But when the Large Hadron Collider gets going again after its refurbishment, physicists hope to discover some of these more weird and wonderful particles.